Determine the force in each member of the truss and state if the members are in tension or compression. Set P1 equal to 20 kilonewtons and P2 equal to 10 kilonewtons. Okay, so today we're looking at this truss structure right here. So let's start with what a truss system even is. So it's a collection of axial force members that are only in tension or compression. Okay, so that's what an axial force member is. It's a rod that is only in tension or compression. And a truss system is simply a collection of those. So what tension is, we got two equal forces, pulling the beam apart like that. Okay, and if the force deforms the beam any, it'll kind of stretch out like that. Okay, it'll get skinnier and longer, I should say. And then compression is the opposite. You got two forces pushing the beam together, and if the beam deforms, it should get a little shorter and a little thicker like that. Okay? And this is a big distinction between beams and rods. Rods kind of a general term. You know, trusses are made up of axial force members, which only are in tension or compression, whereas a beam can have a bunch of shear forces. Generally, the most significant forces on a beam are acting in the shear direction, while the truss and axial force members, they're acting in tension or compression. So we know that these beam members won't have any shear forces like that acting on them. It's simply going to be tension or compression. Okay? So we can start with our find variables real quick, and we'll start dissecting this truss and finding the forces in each member. Okay? We'll be finding the force in CB, force in CD, force in DB, and the force in DA. Okay. So we'll be analyzing the pins right here in this truss system, not the member itself. Okay, so pin is kind of like, you can think of it as like a screw or something that can rotate, kind of. So generally these pins don't resist any moments. It's just lateral forces in the X and Y direction. Let's start the free body diagram of point C. Okay, this is the pin right in the middle right there. Gonna have P1 right here act on the point, 20 kilonewtons. And then we have a rod to the side right here, force C, B, and then we have a force from C, D right there. Okay. So now we can go to our favorite equation. So the moments in the x direction, let's start there. So we have one force acting in the x direction. You can kind of see where this is going. Force CB is simply going to be equal to 0. Because we have no other lateral force in the x right here to balance out this, so this must be equal to 0. And that'll be our first find variable. Zero force cannot be in tension or compression, kind of obviously. So go to sum the force in the y right here. Should be pretty obvious right here. We know that 20 kilonewtons be acting downwards, can be negative, and we know that force CD is be acting upwards. So it equals 0 because this pin is at rest. We should find force CD is equal to 20 kilonewtons. Okay, and this is going to be in tension. Oh, sorry, compression. Compression right here. Okay, so we can kind of look at this. We first write up here in our find variable. Force CD is going to be 20 kilonewtons and in compression. Kind of look at this right here. So we have this force P right here acting down. And we know that there's no force acting here in this member. So this force right here in CD must be equal to P1. Okay, and now to keep member CD right here from moving downward from this from this force P, we know that the pin right here at point D must be pushing this rod up. And so these arrows right here, I should be very clear. These arrows right here are the forces acting on the beam, not the force acting on the truss. So these two forces right here, if they're acting on the pins right here, they are compressing, they're squeezing the members C, D together. Okay. So now we can take a look at the next point we have right here. It's gonna be point D. Okay. So we have three forces. We have three members and four forces acting right here. So we actually start with a little trig. We have a couple dimensions right here. So we know we can make this a 3, 4, 5 triangle to find the angle that this thing is acting right here. Force the member C, then the member DB is acting. So we multiply both these sides by 2. We need to keep the triangle similar. It'll be 4, 3, and 5. So the coefficient will be 4/5 for the x direction right here and 3/5 for the y direction. Okay. So go back down to our free body diagram of point D. Okay. So we know this force right here, force from member CD will be acting down 20 kilonewtons of magnitude. We have force from P2 right here. It's be acting with 10 kilonewtons. Let me double check that. They have 10 kilonewtons. And then we have force dB right here. Acting at an angle. It's going to be 4, 3, and 5 for that. And then we have force dA acting horizontally. Okay. So we can go to some of the forces here. Let's actually start with some of the forces in the Y. Because as you can see, we only have 2 forces right here acting in the Y direction versus in the X direction we have 3 forces. So we can solve one and then move to the next. So we have 20 kilonewtons in the negative direction, and we have F dB acting in the positive direction. We know FDB is going to be acting with 3/5. That's just going to be the amount that's acting in the y direction versus in the direction of the total resultant force. You should find that FDB is equal to 33.3 kilonewtons. And that is simply going to be in tension. Okay. As you can see, this arrow right here is pointing away from the point. So it will be in tension. And so we go back up here. And kind of see this right here. The arrows point in like that from the points. Again, these arrows are being drawn with these are the forces acting on the points right here. So point D right here is being pulled upward from member DB right there. Okay. And then we'll have, to counteract the horizontal force right here caused by this force right here pulling upwards, we'll have this truss right here, dA, kind of counteract that force right here. Okay. And so you go find the magnitude with our equations. So now if we sum the forces in the x, set it equal to 0, we have 10 kilonewtons acting the right direction right here. We have F dA acting the negative direction, and then we have 4/5, 33.3 kilonewtons acting in the right direction. Set it equal to 0. Just using this 4/5 right here to get the horizontal component of member dB. Okay, if you plug it into your calculator, you should find force of dA is equal to 36.7 kilonewtons and it will be in compression. Okay? Be 36.7 in compression. Or our other find variable D be 33.3, and we know that is going to be in tension right there. So kind of look right here at this problem right here. We know that this is acting in compression. So this member is exerting force on those two pins right there. And for this problem, there's no need to find the resultant forces here at B or A. Some problems will ask you to do that. For this one, it's simply asking us for these four members, and CB right here has no force acting through it. Very sad. So that's it. We found all of our find variables right here, and we're done.